Therefore, we gonna go have a look on some problem solving of the common collector. So this will be our circuit that you are going to analyze, and we don't need to do our DC analysis when we consider that this is automatically equal to 1, because from the explanation we say the average voltage for a common collector is always equal to 1. Okay, so when we're gonna calculate, we're gonna see that here you have a parallel between R load and RE, so this will make our RE. Okay, so when you're going to calculate your R in base, okay, you're only going to consider this circuit. Okay, and why did you consider that? Because the R internal resistor is so small that it's not gonna have any effect in our circuit. Okay, and automatically your R in total is going to be a parallel between R1, R2 and this. Okay, so that's how it works. This is when we consider that this common collector it has an average voltage of 1. So now we are going to prove that by doing our calculation. So the first thing we are going to do is to apply our voltage divider, because we can see already that if you apply your voltage divider, you want to get your V base in the DC analysis. But in this case, so sometimes we don't check if it's stiff or not stiff, because already we know that this circuit's gonna have a bigger internal resistance. Okay, so now we come here, we get our V base, you get your V emitter, and then you get your E emitter. You get the value of your E emitter, you substitute to get your internal emitter resistor. Okay, and then now you can apply the average voltage of your common collector, and the answer you get, you can see that it's basically equal to 1. That's why we say with a common collector the average voltage is close to 1. Okay, so that's why we didn't, in the calculation we didn't take long, because we know automatically that this will give us 1. Okay, so after that, if you move down, they ask to calculate what is that? Let's check here an example. We need to calculate our average voltage and as well our average current. Average voltage we have calculated. Now we have to calculate our average current. Okay, so for the average current, we know that it's gonna be I in over I out. Okay, I out over I in. So I out is the current emitter, I in is the current in here. So that's how we are going to get our average current. So when it comes to the I out, which is the emitter current, is going to be VE over RE. Okay, but you can see that here it's a average times VB. Look here, the average voltage is going to be what? V out over V in, but the voltage out is the emitter voltage, the voltage in is the base voltage. Automatically our VE will be the average voltage times VB. So that's why we take this equation, you substitute here, you get your current emitter, and then here you get your current in. But to remember the current in order for us to determine the current in, now we are going to calculate the R in total. Okay, and then when we are doing our calculation of our R in total, because now we are taking in consideration the internal resistance, our R in base will change. It's going to give us this value. Okay, and automatically we have our R in base. Once we have our R in base, now we calculate our R in total. Okay, after getting our R in total, then we go substitute here so that we can get our input current. Once we have our R input current, then we can calculate our average current. Once we have our average current, already we know that our average power is going to be average current times average voltage. But with the voltage close to 1, already our average current will be the same as the average power. Okay, but they say on the load, average power on the load. What do we do about that? We can see that the load is divided by 2. You have your where is it? You have the average power is across all of that. So now we have 2 resistors. We have this for 470 and then 470. So the average power on the load will be divided by 2. So that's why when we come here, the average power was divided by 2 to get the average power of the load. So that's it. And then we're gonna have a look as well on our Darlington problem, which I have explained under the introduction and is not complex. Okay, so you can see that here they give us an amplifier. This is an amplifier, okay, which is basically a common emitter, but is connected with a Darlington circuit. So this is like, it's an interesting question. Okay, so the question is, we must calculate the voltage gain of the common emitter amplifier. This is the common emitter amplifier in green. Okay, but before we do that, we need to get first of all what is going to be the load of this common amplifier. Okay, now look here what's happened. You have here RC is in parallel with what? With this. So basically this Darlington is like our load. Okay, and since it's our load, which means we need to get our R in total there, so that we can be able to calculate our average voltage of the common emitter amplifier. So this is a load to this amplifier there. So we start our calculation by doing the calculation from the load. Once we know what's going to be our resistance of the load, now we can calculate the one for the emitter. Okay, so follow now and see what happened. Okay, so as I said, we start from the Darlington. You apply your voltage divider on the Darlington, your V base. Your V base is this voltage here. Okay, so it's going to be calculating by this equation, and then now you calculate your what? E emitter. Okay, once you know your E emitter, calculate what? The internal resistance. Okay, once you know the internal resistance, what do? Calculate your R in base. Not your R in base straight, but before you calculate your R in base, look here. With the common collector, you need to calculate first what? Your RE, which is a parallel between what? The R load and the RE. Okay, so you have calculated already your internal resistor. You calculate already your internal resistor. Your internal resistor, it's here. This will be our internal emitter resistor, which we have calculated. And now we have this combination here will give us our R in total. Okay, so when you look at the calculation that was done, it was all about to calculate the RE. From the RE, now you apply your R in total, and for the Darlington, as we said, you have this beta AC, which is going to be squared because we have 2 transistors. Okay, and then therefore you're gonna get your R in total. And then as I said, the RC is in parallel with the R in total from the Darlington. So now you have your RC. So that's when you apply the voltage gain of the common emitter, it's gonna be RC over the internal resistor of the emitter, which was given in the problem as 5. It was already given, we didn't need to calculate it. So that's basically what happened. Then when it's come to the average voltage of the Darlington, you know that's gonna be what? Given by this. And then the overall voltage gain of the circuit is gonna be what? It's gonna be the average voltage of the common emitter times the one for the Darlington, so that you can get the average voltage gain. So that's it. Everything's all about to analyze. You analyze your circuit. What do I have in my circuit? So what will be the load to the emitter? And already this question we are solving is like a multi-stage amplifier. So any question, please always ask in the group.